Hello, my name is Emma Joe, and I'm starting a series of well, I'll be doing live streams, but this first one's a recording just so that I can make sure I have the hang of everything before I go into it. Called Emma Joe Explains. The intention being that I have 20 minutes to plan the thing, 20 minutes to do the entire lesson play experience. Um, and it'll all be mathy things pretty much that I'm like talking about. Um, and the purpose for me is to get out of the headspace that I can't post things and to just straight up post things every day. Well, not necessarily every day, but as close as I can get to that point. Um, and the idea that if it's got 20 minutes of prep, 20 minutes of recording, and 20 minutes of anything shenanigans afterwards, then I've done the whole thing in an hour. Okay, so with no further ado, let's get started. I just started my timer. Okay, so today what I'm wanting to talk about is this teaser. What do these four things have in common? Taking off your socks and shoes, stretching and shifting shapes, solving for x in Algebra 1, and the power rule in calculus. My hope is that this covers a nice breadth of personal experience, visualizing things in geometry, and working with symbols in Algebra 1 and calculus. Now, really, all these things are intertwined in one particular way. And even though I want taking off your socks and shoes to be like the most fundamental, like, go-to thing here, I'm not going to start with it. In fact, and even though, secondly, I would like stretching and shifting shapes to be the next thing on your fingertips of like, oh, this is really common. I'm going to start with solving for x because even though it may not come up as much in your daily life, it's a little bit more easy to see on screen that something is weird. So, with that said, let's talk about solving for x. And to be clear, I'm just going to get started here. I'm going to set the frame, and then we're going to come back to it. So typical time you're solving for x in Algebra 1, you're going to say, have something like 3x minus 2 equals. Maybe I should make it have a number that's good. Yeah, there we go. Maybe you have 3x minus 2 equals 7, which is really solving the problem. What number do I multiply by 3 and subtract, and then subtract 2 from to get 7? Or you could think of it as phrased, I have a number. When I multiply it by 3 and subtract 2 from the result, I get 7. What number did I have? Those sorts of things. And whenever you solve for this, I'm going to run through it quickly here. Don't worry, we'll hit it slower later. I'd add 2 to both sides, which gives me 9 on the right, cancels out the 2, and then I divide by 3 on both sides, which would give me 9 over 3 is 3. I'd be like, oh, 3 would have been the number. And sure enough, if I plug 3 back in at the start, times 3 gives me 9, minus 2 gives me 7. It is a number that solves the problem. Great. So that's a thing. Frequently, people think that is just symbol manipulation that has no tying to any of these other things. But there is something actually going on there. And I want to call attention to how similar it is to taking off your socks and shoes now. In the morning, when you wake up, you put on your socks and then you put on your shoes over that in time. At the end of the day, when you want to undo those things, first you take off your shoes and then you take off your socks. This is pretty simple. There's no other way of going about that. You can't take off your socks first because the shoes are over them, right? But this is really, really important that in all of these cases, you do the opposite things to undo them. To undo something, you do the opposite things in the opposite order. Every time. If I put on my socks, then my shoes, then I have to take off my shoes, then my socks. Undo them in the opposite order. Same thing over here. What number do I multiply by 3 and then subtract 2 from to get 7? The same number as 7 plus 2. We're doing the opposite of this thing first, divided by 3. Undoing that second. 7 plus 2 is 9, divided by 3 is 3. It's the same thing. And so you could have actually been doing algebra entirely in words using just this logic, just this, to undo something, do the opposite things in the opposite order. And if it had been expressed in words at the start, you just say the opposite words in the opposite order, and it works. So, ta-da! There's a connection between taking off your socks and shoes and solving for x in Algebra 1. P.S. That always works in all algebra cases in which x shows up exactly once. So long as it's showing up exactly once in your expression, then you're just doing a bunch of things to x in some order, and you just peel them off like an onion, layer by layer. Undoing them in the opposite order. All right, now stretching and shifting shapes. So let's give you a more geometric idea of how this actually shows up physically all the time. Because stretching and shifting are things that we actually like to do when we design things, when we manipulate things. It's like playing with blocks and elastic and what have you. All right, so for this, sound effects are crucial to any instructor's methods. Don't let anyone tell you otherwise. All right, so now I've got this cute little squiggle. I made a complicated thing. Don't worry about what it is. That is not important. I just wanted something that made an interesting shape. This is what makes the curve itself. And this makes a particular point on the curve, which I'm going to have it running throughout this experience, so that way you can see like how individual points move. Okay, so the idea is, consider the idea of me just kind of, let's say this wasn't exactly the shape I wanted for a project or for designing something on my wall or something, and I'm trying to like tell my computer to draw this, print it out or etch 3D print it out or something. And I want to make it bigger and move it up. So beforehand, I might think that making it bigger and moving it up are two things I can do in any order. So let's do the make it bigger. So I'll have the doubled x, or actually no, let's have x1 be, and to make this easier, I'm going to do everyth't in the y direction. So just y, we're going to double. Y1 of t is going to be whatever the squiggly y was, times 2 to just make it bigger. What just happened? Oh, squig. There we go. Don't worry about which weird shape that is. And if I have another one, then this one is going to take what I got from that one and shift it up by 2. What shape do I get? I have a squiggly and another squiggly. But this one I want to make 2. And there you have it. That is a squiggly thing. I'll make it blue. And let me copy paste that so you can see a particular point. Right, and yep, here you go. So that is what happens when you first stretch it and then shift it up. I said to make this easier, I'll be doing everything in the y direction. That's because if I'm not doing anything in the x direction, I can shift this over by 2 in the x direction, and then now we can actually compare them sort of side by side, each of these experiments. So you can see how it's stretched and shifted up. Cool. That's what I wanted. That's what I expected. Except maybe I didn't want, maybe I wanted this shifted up too, and not the important part here. The important part here is what happens if I did the same things but in a different order. So let's do YA in a different way of counting up is with letters instead of numbers. So here I'm going to add a 2 first instead of multiply by 2. And B is going to be the multiplying by 2 on whatever we got from A. All right, let's see what that looks like. This one I'm going to shift over a little further, and now we change it to B. Well, that's interesting. It's just kind of higher up. Let's make you green. Green, green, green. Okay. Okay, so this is very interesting. It's definitely just as big, like the same stretch happened in the end, but it ended up in a different place. If I were to put them on top of each other, like these two different versions, you'd see that it looks like it's just shifted up more. And that's a little unusual. That's not really what you would expect here, necessarily, except there's definitely a good reason for it, which is where I end up depends on where I am when I stretch. When I stretch things, it does this sort of action, right? And as you can tell, I'm stretching everything away from 0. So things close to 0 stay about where they were, while things far from 0 move a lot. And here at the start, everything was pretty close to 0, so if I stretched first and then shifted up, the result was pretty close to the same position. But if I shifted it up first and then stretched, then I had things up here that were getting stretched and doubled, and how far away they were was getting made twice as far away. So this moved further up because it was further up before I stretched. And that has an intuitive making senseness. And you might be wondering, why am I talking about doing things in different orders? Like, I'm not talking about undoing anything, so how can that relate to this? Because at the same time, this idea of undoing things requires you to do the opposite things in the opposite order is closely intertwined with the idea that doing the same two things in different orders doesn't always get you the same result. And that makes sense, because if doing the same two things in different orders always got you the same result, this phrase wouldn't need to be here. It wouldn't matter if I was doing them in the opposite order or not. I undid each of the things. It should be fine. And that's really important here, because if you know this, you can diagnose this problem. If you didn't get what you wanted, you can undo the things you did in the opposite order and see if you get to what you wanted. Or if you really want to know the difference between two different things, do one of them and undo the other and see what you get. In here, in this case, what that would mean is, what if I started with y2 and did the opposite of yb? Let's see. So this is going to be, I'll count backwards from z. So if you started with whatever we got from 2 and undid b, because we're going to undo these in the opposite order, so that means divide by 2. Ignore what that looks like. And then y is going to be starting with yz, and instead of adding 2, we'll subtract 2. Now I've undid the things that were done in A and B, but in the opposite order. Let me see what that looks like. We've got an x squig of t. I'm going to put it to the left, because I know what's going to happen. And put whatever happens here. Oh, look. That's interesting. X squig t minus 2. Oh, wait. I can just copy this. T naught. T naught. And make you purple so that you match. All right. And there we have the dance of the dots. You can see how the result ended up down. And that's sort of the idea here, is that it's not shifted at all. And that's indicating how doing one of these things and undoing the other, the difference between them is not any stretching. They were not stretched relative to one another, but they were shifted relative to one another. And so this shows you how blue relative to green is lower. And that's an interesting idea. There's a lot of clever things you can do once you understand that this can help you toy with this. Let's go back to our algebra. So over here, what we're going to look at, oh, and this is now pretty distracting, I feel. Oh, and I don't have a whole lot of time, so we won't get to the calculus. Unless I squeeze in a little extra time. Okay, well, anyway, for the algebra case, this helps you actually show what's going on in the geometric case. I'll just show off that real fast. What I'm saying here is adding 2 and multiplying by 2 get you different results. And then multiplying, there we go, multiplying by 2 get you different results depending on the order you do them. So if you were to say, take x, double it, and then add 2, that won't get you the same thing as starting with x, adding 2, and then multiplying that by 2. Where that guy, if you were to do that and expand it out to just see what happens, you get 2x plus 4, and you can see that the end result is shifted up by. Closing remarks, calculus next time, and the I always love showing that there's next things to explore. Things you may wonder are what happens if I used 2 as the number in both of these. I could have just as easily gone through in Desmos and every time I multiplied or divided by a thing, called that A and made a slider that was the number 2. And then every time I multiplied by A, divided by A, yeah. And then I could see what happens whenever I change what I'm scaling by. And it's interesting to note how you can even see the purple guy shifting a different amount based on what A is. So even though there wasn't a resulting change in stretch, the amount I was stretching by does change the amount I shifted, which is interesting. And you might wonder why that is, and you might wonder what these things look like when they go negative, which you saw a brief moment of, but I recommend you toy with it more on your own. And this is what I love about Desmos. The moment you have a question and you're like, but what happens if? You could just type it in, make a slider for it, draw it out, see what happens. Enjoy.